So in this video I'm going to do a walkthrough. I'm going to be thinking out loud and I'm going to be answering the questions as we go. Now this is for GCSE Geography AQA Paper 1. This is one of the sample assessment materials, so this is SAM 3, but don't worry about that. Alright, now I've got everything I need other than a calculator and a pencil, a pen and a ruler. Alright, in the exam you will have access to a pencil and a calculator. So first thing, the front you're going to fill your names in. I would do the following. I would write SECO, which stands for social, economic, environmental, challenge and opportunity. So this is just called dual coding. You can use these codes within the exam to help you out. Other things, I would draw a quick compass, north, east, south, west. That's going to help you out when you're doing direction. You could also put phrases such as PEEL for your paragraphs, point, evidence, explain, link. TSE, so when you're making a decision, I agree to some extent. IF1, to make sure you're referring to figures. GCSEA, which is our description strategy, general comment, specific example, anomaly. And finally, TMT, this means that we use that to explain. So I think it's worthwhile. I know there's quite a bit on there, but you're going to use all of them within this paper. Okay, so what's it saying at the front? You got an hour and 30 minutes. It's worth 88 marks. You've got to answer all questions in section A and section B and 2 questions in section C. All right, basically, don't answer glaciers, answer everything else. So, first page. So we've got a figure, the challenge of natural hazards. It's always going to be hazards first. Study figure 1, a map showing tectonic hazards in New Zealand. Figure 1. All right, so what's the key showing us? We've got volcanoes, triangles, earthquakes, epicenter of a particular earthquake. We've got plate movement, plate direction. Straight away, even though you've never seen this before, you should be thinking, right, that's going to be destructive because 2 plates are colliding. That plate's moving towards that plate and vice versa. And this is conservative, all right, where 2 plates are rubbing alongside each other. So it says, use figure 1. Name the type of plate margin at Y. So straight away, we know over here, you can circle it, it's conservative, 1 mark. Multiple choice. Using figure 1, which of the following statements is true? Shade 1 circle only. So it says, all earthquakes are found at plate margin. Well, they're not, are they? So we can put a little cross there. Earthquakes and volcanoes are evenly spread across New Zealand. They're fairly even. I'm going to put a question mark, not sure. Volcanoes and earthquakes only take place on land. Well, no. The majority of volcanoes occur in a line through the central part of the North Island. I would say that is true. There we go. Okay, right. Using figure 1, how much movement will there be along plate margin Z in 100 years? So we're looking at plate margin Z, and it is saying that it moves 47 millimeters per year. So 47 times by 10. Okay, 47 millimeters times by 10 would be 47 centimeters. Times that by 10 again, because we're doing 100 years, times 10 will give us 470 centimeters or 4.7 meters. All right. Okay, this is a bit of a bigger question. Study figure 2, a block diagram showing a cross section between A and B on figure 1. All right, so A and B. So this is here. So figure 2. So we've got Pacific plate, Indo-Australian plate. The oceanic is dense, that's going to be sinking below this continental plate. Alright, using figures 1 and 2, suggest why both volcanoes and earthquakes occur in New Zealand. So, we've got to use both figures, so IF1 and IF2. It says suggest, we could probably use TMT here to help us. Alright, so first thing we're going to do is in figure 1. In figure 1, comma, there are both conservative plate margins and destructive. Could have probably worded that better by saying conservative and destructive margins. Right, what I would do then as well, nothing, so that's Y, just to show you know what you're talking about, and that's Z. Full stop. At a conservative margin, two plates move alongside each other. Comma, this means that friction builds up, comma, this means that an earthquake will occur when it is released. When the friction, you can do things like this in the exam, is released. This means that, let's have another quick look, we're in the South Island. This means that the South Island receives earthquakes. Now, it also asks earthquakes and volcanoes. Now, we could talk about earthquakes again at a destructive margin, but you're unlikely to get credit for saying the same thing again, because a similar kind of process happens. That sinks, it gets locked, and eventually it slips and there's an earthquake. But we can talk about the volcanoes. So, we can refer figure 2. In figure 2, there is a destructive margin, the heavier oceanic plate subducts, that's here, the subduction zone, subducts below we can presume it's continental, the continental Indo-Australian plate, and melts. Full stop. Over time, comma, a magma chamber forms, and this is released as lava during an eruption. This means that the, what's it called? The North Island has volcanoes. Alright, you could, just to show understanding, or maybe help with your planning, conservative, and maybe add no volcanoes. You can put some of your tier 3 vocabulary on there. So, like focus, epicenter. You could have your seismic waves. And again, you could do your destructive, something like this. Alright, oceanic, sinking, subduction. And you get an earthquake there, and where the lava comes out is called the vent. Alright, how are we doing for time? So 11 minutes, so probably 6, 7, 8, 9 marks. Probably a little bit behind, so I need to pick up the pace. Okay. We're looking at something to do with sea ice now. So I studied figure 3, a graph showing the area of Arctic sea ice each between 1979 and 2016. Alright, so sea ice, million square meters. Use figure 3, describe how the area of Arctic sea ice has changed. Right, well, it's gone down, hasn't it? So I'm going to use GCSE. It's worth 2 marks. So, generally, comma, the area of sea ice has decreased a specific example is in 1980. So we're looking here when it was over 7 million square km compared to 4.6 million km squared in 2015. Just to be safe, we could talk an anomaly, so that's what the A stands for. An anomaly is in, what's that, 1996? 1996, when sea ice area is actually higher than in 1980. Okay, GCSE A. If you're in the exam now and your hands and stuff start to hurt, an ache, that's normal. It's intense what you're doing. Give 2 ways that human activity may have contributed to the changes shown in figure 2. Okay, so give 2 ways. You don't need too much detail, but you want to be clear on what you're saying. Alright, so if you put things like burning fossil fuels, deforestation, you'll probably get the marks, but there's 2 lines I'm going to be safe. Burning fossil fuels, e.g. petrol, releases CO2, creating enhanced greenhouse effect. Okay, and number 2, deforestation of rainforest. Could put the Amazon in there if you wanted. Rainforest means more CO2 in atmosphere. That should do it. Okay, so just give. Right, let's carry on. Explain how volcanic activity and orbital change may cause long-term climate change. So how have these caused climate change? You've got to use this means that. You know, if you don't know if you don't know what volcanic activity is, what's a volcano? What's that going to do? Orbital changes. If you don't know what that is, well, think what's orbit? Well, there's the sun. What's the Earth doing going around there? You know, you've got to write something. So, first of all, number one, volcanoes release ash when they erupt that acts like tiny mirrors. This means that solar, which is sun energy, is reflected back into space, comma, this means that temperatures drop. Okay, give my hand a little break. Orbital changes. Right, you might think orbital changes, I ain't 100% sure, just have a go. The orbit of the Earth around the Sun, it's the name of the star, changes. This means that the Earth is sometimes closer or further away, creating long-term climate change. Alright. Other orbital changes named by Milankovitch, remember the Milankovitch cycles, include eccentricity. Okay, so you put some comments in there, that should get you the marks. Alright. Study figure 4, a satellite image of Hurricane Matthew shortly before it crossed Haiti in October 2016. So you know tropical storms, this is a hurricane. You know it's a hurricane, it must be over the Atlantic Ocean because that's what we call them. Haiti 2016. Using figure 4 and your own understanding, complete the following sentences. Figure 4 shows that the pattern of winds moving around the hurricane centre was anti-clockwise because you could just put the pattern of the clouds. Because of the pattern of the cloud cover moving anti-clockwise. At X, the eye of the hurricane, the weather conditions were likely to be, well, in the eye is where you get calm conditions because that's where you get high air pressure. That's it. Calm conditions at the eye. If it was the eye wall, severe conditions. Okay. Study figure 5. A photograph showing the effects of Hurricane Matthew in southwestern Haiti. Right, hopefully you know Haiti is an LIC. So, use figure 2, state 2 primary effects of Hurricane Matthew. So primary is what's happened straight away. 1, houses have had their roofs blown off. What else can we see in there? You could say the houses have completely collapsed. Alright, I'm going to look over here. Debris has blown into roads, meaning that they are blocked. But if you'd have put people may well have died, that could be primary. Whole buildings have collapsed, walls have collapsed, that would be fine. Now I can't see this, but perhaps if there's a person there might be some flooding that you can see that you can't see in this black and white photo, but you'd have colour one in the exam. Alright, here we go then. Use a named example, evaluate the immediate and long-term responses to a tropical storm. So named example, tropical storm, we would use HK, Hurricane Katrina 2005. Evaluate, I would put to some extent. Immediate means straight away. Long term is later on. So if we look at immediate, we can put storm surge, 80% flooded, levees broke. Long term, rebuilding of levees and property. Alright, but this is, we've got to be careful here because it's a 12 marker. If we just dump all our knowledge on there, we're not going to get the marks. We need to go through this in a logical way. Okay, so use a named example. I'm going to answer this as I go through. I'm going to try and talk about the structure I'm using and the assessment objectives that I'm fulfilling. So when this 9 marker, there's going to be AL1, your knowledge, AL2, geographical understanding explanation, and AL3, answering that question, evaluating. Alright, 3 marks for each, plus 3 for SPAG. So if you just dump all your knowledge, you're only going to get maybe the 3 marks for AL1. And we don't want 3 out of 9, we want 6, 7, 8 out of 9. Anyway, let's go. I agree to some extent that the immediate and long-term responses to Hurricane Katrina in 2005 were effective. Now I know it doesn't say to what extent, but you can still make an evaluative statement. I've put my hurricane in. I'm just going to show that I've got some knowledge here, just to set the scene a little bit. A hurricane forms as a low pressure weather system over the Atlantic. Can also be in the Eastern Pacific, but Atlantic Ocean, that'll do. So we've answered the question in one sentence. We've given some knowledge, so AL3, AL1, and a bit of understanding and knowledge there, AL1, AL2. So let's make a point. Point. Immediate effects were, not effects, sorry, responses were effective. There's your point. evidence. Thousands of people were evacuated into the New Orleans Superdome. Right, just looking here, I've realised what I've done. Okay, responses, I've talked about the effects. That's fine in the exam as long as you don't start writing about it. Alright, you're going to make mistakes, it's only natural. Alright, I've been doing this for years and I've just made that mistake. But so we're going to talk about the responses. Evacuating the New Orleans Superdome. Explain. This means that they were protected from the Category 5 wind speeds. Remember, we want spag marks, things like this technical language getting marked, wind speeds. This means that death numbers were lower, in brackets 1800, so we can show that we got the knowledge. This means that death numbers were lower. This demonstrates, that immediate responses in the HIC USA were effective. Okay, that's your link. Actually, I've gone straight to the link. Alright. We'll do next paragraph. So, point, long-term responses were effective. Full stop. Evidence. The damaged levees were repaired to withstand Category 5 hurricanes. Okay, so they repaired the damage. Old levees only withstood or could withstood Category 3 in brackets. So the damaged levees were repaired to withstand Category 5 hurricanes. Old levees can only withstand Category 3. Explain. This means that future hurricanes would cause less flooding. This means that economic impacts would be lower. Do another one. This means that recovery times in future would be shorter. And again, we've got a link. This demonstrates that long-term responses were effective. Now, as you're going through this, you might start thinking, oh, I remember this, I want to say this, oh, I want to say this. That's fine. You got a conclusion. And I always say, save a juicy fact for your conclusion anyway. So, what have we got in here? We've got Hurricane Katrina, we've got the amount of people dead, the size of the hurricane, the levees. We've probably got all our AO1 marks. We've explained quite well, talking about the impacts of the tropical storm and how they're reduced. So we've got most of our AO2, and we made some AO3 comments. To get the major AO3, I think we need to kind of, talk a bit more about the negatives. In conclusion, so this is the end of your answer. In conclusion, both the immediate and long-term responses did reduce economic and social impacts. However, many people in New Orleans believed that this is our juicy comment we haven't put in. The Federal Emergency Management Agency in brackets FEMA were slow to react. Also, President Bush was at a concert. If you remember the lesson, he was playing on a guitar whilst people in New Orleans suffered, and I believe improved preparation and protection methods should be implemented, or should have been implemented, sooner. Alright, you're going to get into level 3 with that answer, and that's what, if you get into level 3, 7 to 9 marks, you're going to get 3 for SPAG. You've answered the question, you said what was good, you've said that what was bad. Happy days, you can move on. So that's section 1 done. Alright, section 2, the living world. Alright, so this is your tropical rainforest ecosystems. Study, how are we doing for time? I've stopped time. Study figure 6, a map showing global forest cover. Figure 6. Use figure 6. Which one of the following statements is true? Shade 1 circle only. Alright, it's going to be tricky because it's in black and white. You'll have one in colour, but we'll have a go. Most of the world's forests are situated between the Tropic of Cancer and the Tropic of Capricorn. Alright, well, there is quite a lot between there, so I'll put a question mark. The greatest amount of deforestation has occurred in North and South America. Well, I would say there's more elsewhere, so that's wrong. A high proportion of the original forest cover has been removed in Africa and Europe. Well, loads has gone there, loads has gone there. Most of the original forest cover in Southeast Asia still remains today. Maybe. I'm going to go with that one. A high proportion has been removed from there and there, Africa and Asia. All right, you could spend 5 minutes on that just double checking, but what's the point? Worth 1 mark. Right, outline one reason for the high levels of biodiversity in tropical rainforests. So let's have a look. Check them still in shot. Outline, I'm just going to put, this means that basic explanation. So, tropical rainforests are found here, here, here at the equator. So, tropical rainforests are found at and around the equator, where rainfall is high, over 2,000 millimeters, and the sun is directly above. This means that there are perfect conditions for a wide range of vegetation to thrive. This means that high biodiversity. You could have said there's loads of plants in the tropical rainforest. This means that there's loads of food for animals. This means that high biodiversity. Alright, but that'll get you the 2 marks. Okay, another graph question. So let's have a look. Study figure 7, a graph showing annual deforestation and land protected in the Amazon rainforest of Brazil between 1994 and 2013. So the bars are the trees cut down, deforestation. The line is the land protected. Deforestation on the left axis, land protected there. Okay. Which statement is true? Annual deforestation was over 15,000 square kilometres in every year between 1994 and 2005. Now, the highest level of deforestation was in 1995 and the lowest level was in 2012. Highest, lowest, I think it's that. The percentage of land protected increased by approximately 20% between 1994 and 2013. 1020, no, it's more, that's wrong. Annual deforestation decreased every year between 2004 and 2013. Well, no, it went up there, so it's that one. Okay. Using figure 7 suggests 2 reasons for the changes in annual deforestation in Brazil between 2004 and 2013. Right, so what's happened? The deforestation's gone down. So I would put 1, greater awareness of the negative impacts of deforestation due to better education. Alright, people are talking about reasons. Another reason, you could have changing government laws, policies, but I'm going to go with debt for nature swaps. It's only suggesting give LICs money for protecting their rainforests. 2 marks. You could have said selective logging means that not as many trees are cleared. You could have said ecotourism works with local people and educates people on it, but those will get you the marks. Okay, next question then. So study figure 8, information about Caracas mine in Brazil, South America. Fact, so it's the largest iron ore mine in the world, 6.5 billion tonnes of iron ore, over 100 million tonnes mined each year, gold, manganese, copper, creates power, it's powered by a high HEP station, you've got a railway. Alright, so what we're going to do, we're going to have a look at the photograph. We can see large scale mining, obviously going to have negative impact on the environment. It's scarred the landscape, air, water pollution. What's the question you want us to do? So, using figure 8 in your own understanding, explain how deforestation can have economic impacts. So we've got a IF8, we've got to use our own understanding, maybe use Amazon as a reference. Explain, this means that deforestation, which is cutting down trees, economic impacts. It doesn't say positive or negative really, so let's have a look then. So use figure 8, let's pick one. In figure 8, comma, there is a mine that extracts, what's it extracting? Iron ore. Full stop. This means that people are employed, they've got a job, comma, this means that disposable income, so money you can spend on luxuries, and standard of living, SOL, increase. Demonstrating positive economic impacts. What else? We've also got gold mines in the area, so we can write gold mines also create jobs, comma, this means that GDP of, in this case, is it Brazil, increase. This means that tax revenue for government increases. This means that further investment can be made in infrastructure projects, maybe new roads, new railways. Further, rest my hand for a sec. Developing the economy. Also, in figure 8, it demonstrates that energy comes from the Tukurui HEP hydroelectric power dam. This means that there is cheap and plentiful energy. This means that further industry can develop. Alright, we've got to keep an eye on the time. It's 6 marks. You're going to get most of the marks there. You could have brought in some facts about Amazon. Okay, what do you know about Amazon? Maybe cattle ranching in the Amazon. You might just want to pop that at the end. Cattle ranching in the Amazon also creates economic impacts. Alright, but you could also go the other way, saying, well, when you've done mining, when you use the land for mining, the landscape's scarred and polluted. In the longer term, it's going to have economic negative impacts because the land can't be used for a long time. But we've got to bear in mind this is a 90-minute exam. So what have we got here? Study figure 9, a diagram showing energy flows in an ecosystem in the UK. So remember, in a UK ecosystem, the arrows show the direction of energy. Same thing always happens. The sun is photosynthesizing, the tree's photosynthesizing using the sun. Producer, the rabbit eats the producer, primary consumer, the fox eats the rabbit, and they poo-wee and die and get decomposed. All right, producers. So producers make energy via photosynthesis. Okay, and you've already got the mark. Provide food for consumers. Might be a bit overkill. You probably already got the mark there. One reason why energy is lost at each level of the food chain. This is a difficult one, but you've got to put energy is used for movement and respiration. So that's why energy is lost as you go through the food chain. Okay? If a disease, alright, your own understanding, complete the following sentences. If a disease reduced the number of primary consumers, one effect on the food chain would be. So we're either going to have more producers because there's less rabbits eating them, or less foxes because there's less food for them. So I'm going to put, there will be that there are less foxes as the number of rabbits which is their food has decreased. If your hand's hurting, that's fine. It's hard work, this is. Decomposers help to return nutrients to the soil by, say, thinking worms and fungi and things like that. Breaking down dead organic matter. If you spell like that. If you spell the word wrong, don't worry about it. Okay, big one. Pretty much always going to have a 9 marker on cold environments. First of all, get rid of that. We don't want that. We're doing cold environments. Choose one of the following environments. Done. Tick the box. Done. To what extent is your chosen environment at risk from human activity? If you just say, in Svalbard these things are good, in Svalbard these things are bad, alright, you're not going to answer the question properly. So you will pick up marks. You've got to read the question, what's in front of you. So, to some extent, chosen environment, well, we'll do Svalbard and Alaska, are at risk for human activity. So human activity could be settlements, so where people live, could be tourism, mining. All right, so what should we say? I agree to some extent that cold environments such as tundra and polar biomes are at risk from human activity. Full stop. Let's put a bit of AO1 knowledge in there. Cold environments are fragile biomes or ecosystems that experience sub-zero, which is below zero. We can put below if that's easier. Below zero temperatures for much of the year. Okay, you can put up to minus 50 degrees Celsius, more knowledge. Okay, what we're going to do next. So we're going to be talking about Svalbard and Alaska for the maximum marks. I'm going to go with Alaska to start with. So Alaska in North America is at risk of damage due to human activity. So point. So we made a point. Evidence. Footprints and tire tracks can leave scarring on the landscape, demonstrating how delicate they are. And this is why the Trans-Alaskan Pipeline TAP has been built on stilts. I apologise for people talking very loud in the background. Explain. So we made our point that it's damage due to human activity. We've given evidence. Now we're explaining. This means that hot oil, 47 degrees Celsius, will not melt the permafrost. This means that the natural environment is protected. This means that there are less chances of an oil spill during an earthquake. I appreciate that doesn't flow probably as well as it could, but we're just sticking with our peel structure. We've made a point, we've given some evidence in a place, and now we're explaining it. Alright, so we're explaining it. You could probably do it, point, evidence, explain, evidence, explain, evidence, explain, then link. It'll take you longer. However, I just want to get through this exam and get the highest possible grade, aiming for a grade 9. Link, and this will still get you into level 3. So, link. This demonstrates, this is key, because this is what the question wants to do, that human, I'm going to start writing here so I've got more space, activity can impact cold environments. However, this can be managed by using technology. Alright, so we've done Alaska, we've answered the question, you're in level 2 for definite. Now let's show we've got a wider understanding, and we'll just put something in. Tourism can have a negative impact on Svalbard. There's your point. Evidence. 50,000 tourists visit the Norwegian, just place knowledge, territory every year to see the northern lights or polar bears, glaciers, whatever. On the one international, what's the only airport? Okay, explain then. So this means that more energy will be needed, e.g. heating hotels. This means that more pollution, air pollution. This means that a greater contribution to the greenhouse effect, or the enhanced greenhouse effect, potentially causing glaciers in Svalbard to melt. Okay, link. This demonstrates how human activity can put cold environments at risk. However, the Svalbard Tourist Board actually limits numbers to 50,000 per year, making it more, on that space up for something right on the back, more sustainable. Remember, providing for people now without damaging the environment for future generations. Right, final thing, juicy fact in conclusion. So you could have wrote about the fishing in the sea. These things will come to you in the exam. In conclusion, many human impacts are damaging, putting at risk. However, human strategies such as limiting fishing in the Barents Sea allows fish stocks to recover, reducing risk. Okay, so in the exam, if things come to you as you go, just try and make it look as if you've done it on purpose. Whack them in the conclusion. Alright, next question. Alright, so we finished the living world. We're on to section 3. We do coast, rivers, not glaciers. So you're going to get maps in the exam. That's why you need to know your grid references, your symbols, scale, distance, relief. So study figure 10. A 1 to 50,000 ordnance survey map of the Barmouth area. So basically everything's been shrunk by 50,000 times, scaled down. So figure 10, we've got something labelled Y, looks like a spit. We've got something labelled X, it'd be better in colour. Is that a cliff? Let's have a look. So, first question. Using figure 10, give the 6-figure grid reference for a shingle beach. Okay, so in the exam you'll have a key. Right, this looks pretty shingly to me. This looks pretty shingly. So the best thing to do is just go through the grid references. So 616138, 616138 takes us to about there. Don't know about that. Okay, 609138. 609138, that's in the middle of the sea, it's not that. 596106, 596106, yeah, it's there. Gonna go with that. You could check the last one, but it is there. Alright, maybe put an arrow. Using figure 10, which one of the following statements best describes the feature of grid square 60O16? So, 6016, looking in here, 6016, double check. What we got? So, we got a beach with some groins, looks like a train station. So, an area of flat land with a small stream and a salt marsh to the north. Well, it's not flat. A steep cliff, a road and railway, no buildings and a narrow beach. There are some buildings there. A long narrow piece of land, car park, railway and wide beach. No. No car park, the beach is not wide. And finally, a beach with groins, a small coastal settlement and an A road. It's got to be that one. Let's have a look. Yeah, so there's a little town, the beach has got groins, so these lines going out of groins. Remember, these are 1 markers. Next question, need a ruler for this. How long is the coastline between X and Y? Shade 1 circle only. So X and Y is so how far is that line? 6.4, 6.6. So we divide it by 2, so it's about 6.4 divided by 2 equals 3.2. It's got to be this one. Those are too small. It's over 6 centimetres, so it can't be that. It's got to be D. Alright, let's just double check it. It is a nice easy mark, this. Yeah, that's about right. It's 6 point something. And remember, generally you half it. So 6.4, and just go to the nearest one. Okay. Study photograph 11, a part of the coastline shown in figure 10. Using figure 10 and 11, which direction was the photographer facing when the picture was taken? Right, so we've got the spit and there's Z. So we've got to find the spit and we've got to put our pen along the spit. Okay, so if we find the spit, put our leg along the pen along it, because that's what we're looking at, isn't it? That is southwest. Yeah, so an answer for southwest. Happy days. Best thing to do, put your pen in the middle of the picture. Okay, using figures 10 and 11, suggest one reason why the area in grid squares 6014 and 6015 show evidence of deposition. Hopefully you'll have a map in the exam. So what was the grid square? 6014. 6014. 6015. So evidence of deposition, we're talking about things that are put down. This is quite a tricky one, because it's saying what evidence is there. You'd usually be looking for things such as a beach or whatever. I would go with, when we're talking about transportation and deposition, constructive waves, or this one, longshore drift, transports, material along the coastline. That'll get you the mark. You could say forming spits if you wanted to, but I don't think you need to. Okay, feature Z labelled on figure 11 is a spit. Explain the formation of a spit. So TMT. Doesn't say use figure 11, so you don't need to put in figure 11. So this is basically longshore drift, landform changes shape. I would do this. Swash, backwash, swash, backwash, swash, backwash. You've already picked up a mark there. Remember, it comes back in right angles. So, as eroded cliff material falls into the sea, prevailing winds cause waves to hit the beach at an angle, and gravity, man, you got some quality tunes in the background. Gravity pulls waves and material back into the sea at 90 degrees. This means that sediment moves along the coast. This means that when the coast line changes direction. So if you look here, the coastline, here's the sea, prevailing wind has changed direction. This means that when the coastline direction, this process of erosion and transportation continues, creating a finger-like landform called a spit. If wind direction changes, the spit can form a hub. Alright, and you can do another little diagram here. Swash, backwash, swash, backwash, swash, backwash. There's your spit. Just to show your understanding. Alright, you just need to rehearse that and get it in there. Hard engineering strategies are effective in protecting the coastline. Do you agree with this statement? Explain your answer. So, they are to some extent. We're looking at groins. We're looking at sea walls. We're looking at Lyme Regis. We're looking at the 20 million cost, circa 20 million. Alright, do you agree? Well, I agree with some extent. This means that. Let's go then. So, I agree that hard engineering strategies such as groins and sea walls are effective to some extent. Okay, we'll start with sea walls. We can do peel for this if you want. Sea walls are concrete structures based at the base, or positioned, probably better, at the base of a cliff. For example, they have been constructed in Lyme Regis, Dorset, as part of the 4-phase 20 million pound coastal management scheme. This means that wave energy is reflected back out to sea, comma. This means that there is less cliff erosion via hydraulic action. Full stop. This demonstrates that sea walls are effective, however, they are expensive and look ugly, or you could put not aesthetically pleasing. Alright, so I have done a peel here, so I've said something, I made a point about sea walls, I'll give some evidence, I have explained, and then I have linked here. Alright, so we've talked about the sea walls in Lyme Regis, we've said how much they are, they've said what they do, but we've talked about that they're expensive. We now do groins. Groins have also helped Lyme Regis. Full stop. Evidence. They constructed a number of both rock and timber, which means wooden groins, to prevent material being moved along the coastline via longshore drift. Full stop. So we can explain. This means that beaches are wider and steeper. This means that wave energy, when they go up the beach, its swash is reduced. This means that there is less erosion and Lyme Regis is protected. Okay. The final thing, link, we've already talked about the cost and the aesthetics, ugliness. We'll talk about something slightly different. This demonstrates that groins are effective. However, people argue that it simply moves, you can put in inverted commas, the problem elsewhere, as the trapped sand or shingle starves other beaches. Just a final one. Also, they disrupt natural processes and potentially ecosystems and habitats. All right, quite a long answer. I'm not going to do a conclusion. 6 marker. We've more than definitely got into level 3 there. We have made a statement. We have given 2 examples. We've given a place, some facts. We've talked about the opportunities and the challenges. All right, and we've linked back in each paragraph. Okay, wicked. So now we're on question 4, our last question. So we're looking at another OS map. So said you'll see maps all the way through. 1 to 50,000, the River Cuckmere in Sussex. Give the 6-figure grid reference of the mouth of the River Cuckmere. Okay, 512983. So 512983 is about there. I don't think it's that. 516977. That looks about right, but we'll keep checking. 523985. Now it's up there. 515985 up there. So it is C. Okay. Using figure 12, which grid square matches the following description? Actually, go back. No, it's B, isn't it? So the way we do it is we cross out that answer and that answer because it's there. 516977. So in the exam, if you question yourself, just have a quick look back. Okay? Right. Using figure 12, which grid square matches the following description? There is a meandering river, land is flat in the south, but it rises to 70 metres in the northwest. 2 secondary roads pass through the area. Quite a lot of stuff going on. We're looking for a bendy river, flat land in the south, 70 metres northwest. So 5297. So 5297. I don't think it's that one. 5202. 5202. Well, there's a bit of a meandering river, but the land's not flat at the south, so it's not that one. 5101. So along the corridor, along the stairs, 5101. Here we go. So I think this is it. We've got meandering river. The contour lines, which are these lines here, are far apart to the south, and to the northwest up here it gets steeper, so it is C. Just double check. 5002. 5002. No, it's definitely not that one, so it is there. Here we go. Study figure 3, a photograph of the River Cuckmere and its valley. Figure 13. So first of all, got 2 things labelled, Z and X. Looks like this is the natural river course. This looks straightened, so they've done some river straightening. And we've got the large flat valley, floodplains, and then we've got the river coming into the mouth. This is the estuary. Here's the coastline, and here's loads of sediment deposited. I wonder what they're going to ask us about this. Okay, so using figures 12 and 13, give the grid reference of point X on figure 13. So, point X on figure 13. So, X is where we've got the straight channel. I'm thinking it's somewhere here. So, 516. 516, 517, 989. So if we go, it's not 517985, I don't think. Let's have a look. Let's check it out. So 517985. 517985 is about, actually it is, it's there, isn't it? 517985, it's there. I think it's that. Let me just check. 513993, it's not there. 516993, it's not there. 520991, it's not there. So yeah, it is the first one. So that is our answer there. Right, using figure 13, describe one feature of the river Cuckmere when it reaches the sea at point Y. Alright, so, well, I just said the deposition of sediment. Okay, so reaches point Y at the sea. Just double check. Yep, there is deposition of sediment. Okay. Use figure 12 and 13. Suggest why there is a straightened channel next to the natural river meander. Okay, so the point of this is to get rid of water quickly. So it diverts the water, rather than the water having to go all around the channel, it comes in a straight line straight out to sea. Now ultimately, that is to reduce flooding. It's hard engineering to reduce flood risk. Okay, or something along the lines of to take away excess water, but flood risk is probably the best thing to be doing. Alright, next, explain the formation of a floodplain. So let's have a look at feature Z. So here's feature Z. Okay, it's talking about this area. So even if I didn't know anything, I could be like, well, why is this feature like this? So I could just say what I say. I've got flat land next to the river. So in figure 13, comma, there is a large flat floodplain. That excess river water will flood onto should river discharge, that's the amount of water in the river, exceed bank full capacity. So we're using some complex terminology there. These are formed over time as when a river floods, it transports smaller sediment a large distance or a long distance, and heavier sediment a short distance. And you could draw diagrams to represent this. So one, that's normal discharge. Two, when it floods, you get the large material there. Large sediment. Small sediment. And three, you get a floodplain and you get these things called levees. Okay, so this will create large, flat, fertile floodplains covered in alluvium, which is what the posh word for the nutritious bits of material are deposited when a river floods. Fertile alluvium and steep sided levees on river banks. Okay, that's a bit of a tough question. As you can see, I'm slowing down thinking how best to answer it. You'd probably normally expect them to say explain the formation of a levee, but it's pretty much the same process. You could also talk about meanders and how meanders down the river. Alright, this is what they might look like to start with, but over time, because of erosion on the outside, deposition on the inside, they migrate across the floodplain. So it might look like that. Okay, is this the last question? So you know, right, so in the exam you're thinking, right, I've got 6 minutes left, hopefully, or more. Let's have a go at this. The causes of river flooding, so you could think Boscastle, are usually the result of human factors. So we have got drainage systems is human factor, and impermeable surfaces. We could also mention deforestation. Do you agree? I agree to some extent. Explain your answer. TNT. So, final question. I'm going to write across here so I've got enough room. I agree to some extent that river flooding, such as what occurred in Boscastle, are usually a result of human factors. You can use any flood. There was a flood on the news this morning, so Southwest England 2023 flood, you could use that example just to show that we know what we're doing. Human factors include deforestation, drainage systems, and impermeable surfaces. Okie doke. So we could peel this, I suppose. Point. Cutting down trees causes flooding. Evidence. Removing the canopy layer of woodland reduces vegetation interception. Okay, so if we've got a tree cut down and we've got a tree that's not cut down, the rain doesn't get stopped by the leaves and the branches, it just hits the stump. If it's still there, goes straight to the river. Explain. This is where we're going to start banking the marks. This means that surface runoff increases. This means that the lag time, that's the amount of time it takes to get from the cloud to the river, decreases. This means that rivers cannot drain quickly, causing floods. Link. This demonstrates how human factors cause flooding. Another point, so impermeable surfaces is a nice one because you can talk about the rock can't infiltrate. So impermeable surfaces cause flooding. So it's a point, isn't it? Evidence. Building concrete and tarmac on the roads and car parks reduces infiltration. Okay, explain. This means that surface runoff increases, lag time decreases, and flooding becomes more likely. Link. Again, this demonstrates yet another cause of flooding. Now, if you had 2 minutes left, you could do a conclusion. You mean level 3? But you could do a conclusion. You could show real depth of understanding and link it to physical. You can't write about physical, you won't get marks. But I'm just going to do that because I've got time. So I'm going to go over here. So, in conclusion, human factors are significant. However, we cannot discount or ignore physical factors that also contribute such as relief and heavy precipitation. You're just showing the examiner that you've got a brilliant understanding of both the content and the question. And that's it. We get to glaciers, we stop. If you had any time left, okay, you could go for it. It's up to you. You probably know how you work best. You could check the smaller one, so reread the question. Have you got the question? Have you answered what's in front of you? Or you could look at your multiple choice grid references questions if that's something that you know you might have rushed through. If you look at your extended writing, so this was the hard engineering one, you might remember another fact. So you might say the seawall was 500 metre seawall. Immediate and long-term responses to a tropical storm. You might think, I don't know, you might remember something you did in Key Stage 3 and you might want to give another example, or maybe give an example of how in LICs the impacts are worse than in HICs. Is it impacts or responses? The responses are slower, so on and so forth. Alright, and once you're done, happy days. Our final thing you could have put on here, SOL, QOL. Alright, hope that's been helpful. Bye bye.